This is a recording for notes for pre-calculus for section 3.4, exponential and logarithmic equations, and this is part 2. Last time I ended by asking you to try some problems, and now we'll just go over those problems. I have them pre-worked out, and so I'll just kind of show you my work as we go and reveal that to you. So the first one is e to the 2x equals e to the x squared minus 8. So the bases are the same, so we can set the exponents equal to each other as we look at that. And so the first thing we'll get here, and let me see, there we go, is oh, I know what it is. Sorry, I had forgotten how I did this, but now I remember. There we go. So that is 2x equals x squared minus 8, and then we can set that equal to 0, factor, and we get as our final answer then that x equals -2 or x equals 4. Then on this next one, we get 5 to the x alone, first by dividing by 2, and then take the log base 5 of each side, and then we get x equals the log base 5 of 16, which is the log of 16 over the log of 5, or the ln of each, and a 1.723 for that one. Then let's look at these next two. So then for this one, we get e to the x is 30 when we add 7 to both sides, and then take the ln of each side, and x equals approximately 3.401. Then on the next one, add 4, divide by 6, and take the log base 2 of each side, and then subtract 5 from each side and get approximately -4.778. And then for the last one, I'm not going to change e squared into m. I'm just going to know that it's e to the x times e to the x, and I'm going to use that as I factor that one. And then for this last one, we factor that, and I have that in a little funny order. So e to the x equals 4, e to the x equals 3, and I did each of those to get those results as we look at that. So by all means, let me know if you have questions on that, and then we'll move on to solving logarithmic equations as the next little part here. So solving logarithmic equations. To solve a logarithmic equation, you can write in an exponential form, and so we call this exponentiating each side. So since it's the ln of x equals 3, we know that the base is e, so we'll raise each of those using e as the base, and that's called exponentiating, and then x equals e to the third. So something to kind of make sure that you're careful with is as we do these, and I'm going to put a little star here, so write yourself a note, and that is make sure that you check your answer for these, or check that your answer, I'll say it that way, that your answer is in the domain. And then I'll put in parentheses and works. So just a little note to self that we want to check that that's in the domain, because this is a situation where we can do everything right, but still not get the correct answer, or not something that will work in the domain. So let's go through this, and I will say that you can just change it from logarithmic to exponential form, but sometimes that's just not going to be in your best interest. as we go. So example 6 and letter A, so the ln of x equals 2. Remember the base here is e, so I'm going to exponentiate it by raising each side to e, or raising each side to a power of e. And so e to the ln of x equals e squared. And I think maybe I even did one like this, or maybe it was this one. So e to the ln of x is just x equals, oh, that should have been e squared, sorry, equals e squared as we look at that, and that too was originally in black because it was the original problem. Then on this next one, we can actually use a one-to-one property because we've got log base 3 of this equals log base 3 of that, so that means this must equal that, and I did not check that, but the ln of e to the x, so let me check that. The ln of e squared is 2, because, kind of think about that's 2 ln e. Ln of e is 1. 2 times 1 is 2. So that one did check. Sorry to start the next one. Then in this one, log base 3 of parentheses 5x minus 1 equals log base 3 of parentheses x plus 7. So that means that 5x minus 1 equals x plus 7. We'll subtract x on both sides and add 1, so that'll be 4x equals 8, divide by 4, and x equals 2. And then we'll do our check again. So this is the log base 3 of 5 times 2 minus 1, and we're comparing that to the log base 3 of 2 plus 7. So that's the log base 3 of 10 minus 1, which is 9, compared to the log base 3 of 2 plus 7, which is also 9. So that's okay, and that's defined. Keep in mind, if we had gotten -9 in one or either of those, even if they were both -9, that would not have worked. So this one worked out, so we're good to go. Now, letter C is on the next slide. If you want to pause this and try it, go ahead and see how you do. A little more complex. If you want a hint before you pause it, my hint is make sure that you get it to be the log of base 6 of one thing equal to the log base 6 of another. So my first step here is going to be to condense that left side. They're subtracted, so this is the log base 6 of 3x plus 14 divided by 5 equals the log base 6 of 2x. So now I can say, oh, it's the log base 6 of this equals log base 6 of that. So I can say 3x plus 14 divided by 5 equals 2x. And now it's really reduced to an algebra problem that I can solve. So I'm going to get rid of the fraction by multiplying by 5, and then I'll get 3x plus 14 equals 10x. I'll subtract 3x, so 14 equals 7x, divide by 7, 2 is equal to x. And then I want to go back up and just check that. So it's the log base 6 of 3 times 2 plus 14 minus the log base 6 of 5 equal, or box checking to see if it's equal to log base 6 of 2 times 2. So this is log base 6 of 4. This is the log base 6 of 20 minus the log base 6 of 5. Both of those are defined. Just kind of keep checking that and using that condensing. This is the log base 6 of 20 divided by 5, which is 4. So yes, this does check as well. So awesome for us. Now, our next problem is just solving another one of these. Why don't you try this one? Get that ln of x alone, and then if you want to try exponentiating, that would be great. Okay, let's see how we did. So we want to get the ln of x alone, and that's going to equal negative a half. And then we're going to exponentiate using e as our base. E to the ln of x equals e to the negative a half. And then e to the ln of x is equal to just plain old x, and x equals e to the negative a half. Using a calculator, then we get 0.607. So hopefully you're getting into the routine of how that's going to work. And you can check that by putting that decimal in and see if you get approximately 4. I'm not going to go through that process for this one. Then the next one we're going to do is number 9. We're not going to do number 8. And this is the log of 5x plus the log of parentheses x minus 1 equals 2. So keep in mind what our base is. 10, that is correct. And why don't you try this if you want, and then we'll go over it. If you need a hint, my hints are condense the left side and then exponentiate it with that base of 10. And if you still want to try it, fine. Otherwise, let's see how you did. Okay, so we get that condensing of that first, then we're going to exponentiate using a base of 10, and then we get a quadratic. Notice I'm factoring out a common factor of 5, makes it easier to factor, and I get those two answers. Am I done? So I'm just going to say exercise caution, because if you don't check these, at some point you can get in trouble. And, you know, we've checked a lot of things so far and everything seems to work out. So you might get a little lackadaisical. Wow, big word. And so I'm telling you exercise caution. So let's check that and see how we do. And let's see what happened when we checked this. And so when we put in the -4, notice we get things like log of -20 plus log of -5. And you have to be cautious and kind of think about it as you go, because if you did combine those together and multiply, you'd get positive 100. But in this case, the log base 10 of -20 is saying 10 to the what power equals -20. And there is nothing. So this is not defined. And so then that means that -4 does not work. Then we still want to check 5, and we get log of 25 plus log of 4. Those are both defined, so we're okay, which is then log of 100, which is 10 to the what equals 100, and it's 2 as we go. So that is problem number 9. Then we're going to move on and have an application problem. Oh, and I put my check mark there. Oh, sorry. And then there, our application problem. And before we do that, just a reminder of, and you do need to know this for your exam when we get that far, and that is the formulas for interest. And so A equals P times 1 plus R over N to the NT, if that is calculated in multiple times during a year, or A equals P times E to the RT, if that is compounded continuously as we look at that. So just a little reminder of those, and let's see what we have to use in this application problem. So you invest $100 or $500, excuse me, at an annual interest rate of 6.75%. Compounded continuously. How long will it take for your money to double? And you're going to find that, you know, you're going to be asked about doubling or tripling or things like that. And so first, let's just kind of notice we're compounding continuously. So it's A equals P times E to the RT. And let's just make sure we know what our things are. P is our principal, and that's $500. And R is our rate, which is 6.75%. So that's 0.0675. And time is unknown, and A. So that capital A they don't really tell us what it is, but they say we have to double things. So if we know we're starting with $500, if we're going to double it, then we're going to end up with $1,000 right there. So we do know A, even though they didn't tell us. And actually, they could have told us no amount of money and still asked us how long it'll take our money to double. And you might be thinking, no, they couldn't. How would I know? But think about what happens, and you'll see this when we go through the problem. I can say if I don't have an amount that my initial amount, my principal is 1, and then doubling it would just be 2. And watch how that comes into play as we work this problem out. So, oops, let me put that line back on there. And so I'm just going to write 1,000 in there because I have to kind of know or figure that out. And it says how long, so time is what we're trying to figure out in this one. So there were kind of two things we didn't know immediately, but that A we can kind of figure out. So let's put those in, and we get 1,000 equals 500 E raised to the 0.0675 Now, notice this, our first job is going to be dividing by 500, and so I'm just going to put it so I can see my problem. When I divide by 500, 1,000 divided by 500 is 2, and so I'm going to get 2 equals e to the 0.0675 And so think back to what I had said before. If I put in $1 and I get out 2, well, that would have been putting a 1 there and a 2 there. And look, I get a 2 there, and it's like having a 1 there. So I don't have to even be given an initial amount, and I can still figure out how long it's going to take for my money to double. I mean, isn't that awesome? I just love mathematics. I hope you're enjoying it also. And so then now we want to do that kind of, oh, look, it's e to the power and our variables in there. So let's take the ln of each side. So the ln of each side, and I get the ln of 2 equals the ln of e to the 0.0675t. And when I do that, that's going to be on the left, just the ln of 2. On the right, then, I'm just going to get my 0.0675 t. To solve for t, I'm going to divide each side by 0.0675. 0.0675, and then whatever the ln of 2 divided by 0.0675 is, that will be approximately equal to t. So if you have a calculator, go ahead and find that. Otherwise, I'll tell you it's about 10.27. So really, no matter what I kind of had put in there, I can say it will take about 10.27, and time is in years, years for the money to double. I'll say the money to double. So awesome problem right there. And I do have a slide that just kind of shows it graphically. It's always nice to just kind of see a little extra thing here. And so the balance in the account will double after approximately 10.27 years. This result is demonstrated graphically below. So a nice little graph to look at. And then that concludes this lesson, exponential and logarithmic equations 3, 4. And our objectives were to solve simple exponential and logarithmic equations, and then to solve more complicated exponential equations and more complicated logarithmic equations, and to use exponential and logarithmic equations to model and solve real-life problems. Hope you're having an awesome day, and that concludes 3.4.